Hey, Kal-El, the microwave is broken. Can you use your heat vision to warm up my coffee? Kal-El is indeed Superman's given name on his birth planet of Krypton. So looking at microwaves, not just ovens of convenience, the next portion of the EM spectrum will be looking at, but not looking at, because you can't see anything in the EM spectrum except this tiny sliver of visible light. So we will be looking at some applications of microwaves. First, we'll give you a historical context of when and who discovered microwave radiation. It's back in 1888. The German Heinrich Hertz, indeed for whom the SI unit of frequency is named after. Microwaves, they range from a few centimeters to about a tenth of a centimeter. Another name for a tenth of a centimeter, the millimeter. And they're called micro, not in relation to SI prefixes, but micro meaning smaller waves compared to radio waves. Just as each of these can be broken down into subcategories, such as with the light, we can break this into the various frequencies that we see and interpret as color. We have subsections of the microwave band, L band, K band, and you don't need to memorize that. You just need to know that microwaves are the range of a few centimeters to about a tenth of a centimeter. So small microwaves. And as we mentioned, we don't visibly detect these with our eyes, but we have some great applications and uses of this radiation. Although maybe, if you wanted to, you could look closely and see a microwave. Yep, that's pretty terrible. The synthesizer, after helping develop the first radar systems. Now radar, one of the very first applications of microwave radiation, is the Canadian physicist Hugh LeCain turned his focus to developing beautiful sounds using techniques from radar and atomic physics. He created the first volt-controlled synthesizer. Now radar does stand for the RA, radio, D, detection, and ranging. And we do mean radio in terms of radio waves, but there's this area between radio waves and microwaves that there's overlap, if you will. And I don't mean overlap of waves you learned in previous traveling light study guide that two or more waves sharing the same space is interference. I just mean this kind of overlap in the sense of where you have the higher energy microwaves versus lower energy radio waves. Kind of think of it as that transition summer between grades. So you graduate from the 8th grade, you're excited to come to Ridgeline High School in that summer. It's like it's the end of the 8th grade, but you're starting freshman, kind of in between zone here. And this is an area in which microwaves can be used within the radar systems of detecting and ranging. Very pivotal for the use of war detecting airplanes. You could send out a beam of radiation in the microwave range, so the higher energy microwave, lower energy radio waves, and it would hit the target aircraft and reflect back. And I don't mean hitting it in a sense of causing damage, but the waves and particles would be reflected back from the solid surface compared to the less solid fluid air around, and it would be sent back to the surface of the Earth. Using kinematics, you can see how the distance is actually determined or calculated. So you have a straight line motion here, so a vector. Velocity is the rate at which you displace. They certainly know at what time they send out the microwave radiation, and that is the time there. They know at what rate, what velocity they're able to send that microwave radiation out. And the good old use of algebra, if you know two of the three variables, you can find the third variable. Now, in that we're trying to find how far away the vehicle is, you'd actually want to take your final answer and cut it in half. And the reason you'd want to cut it in half is you don't want the total distance there and back. You just want the one way. Now, since many of us think microwaves, we think of microwave ovens. Don't want you to think that this signal is being sent out and it is heating up the aircraft or the occupants within the aircraft. This is not the strength or the intensity of microwave radiation that could be used to heat something up. Now remember, frequency on this EM spectrum, frequency is going to tell you the type of radiation, whereas the amplitude is going to tell you intensity. So a greater amplitude, both of the same frequency, if these are microwaves, this one is more intense, less intense. So remember in Physics A, with the Waves Here We Go study guide, you could increase energy or have an energy increase by higher frequencies, and that's a higher amplitude, or higher frequencies, the rate at which the oscillations about equilibrium occur. So the frequencies are going to tell you what type of radiation, whereas amplitude is the intensity. Comparing this EMR to your mechanical radiation, just a reminder, when you had increases in mechanical radiation amplitude, that was registered as an increase in volume. When you had mechanical radiation that was higher frequencies, that was registered as higher pitches. Percy Spencer is the individual that we probably should give a lot more credit to in our lives, especially for our consumption of food, as he is the individual who invented the microwave oven, the oven of convenience for us. And he was an individual who worked at the radar range company, and certainly everyone in humanity, I hope, would be an advocate for peace. As World War II was beginning to look like we may come to a peaceful solution eventually, that the employees and engineers at the radar range company, Raytheon, were going to be out of work. And he was constantly trying to think of ways to apply radars for non-military purposes, as of course the demand would greatly be dropped for radars in jet fighter type airplanes and bombers. And it's one of those serendipitous events that he had that allowed him to continue in his company's operations, and for us to have one of the more common in our everyday uses of microwave ovens. So we'll let the History Channel explain to you the discovery and a little bit of the evolution of the microwave oven.
It's the epitome of modern convenience, the ultimate time saver in a high-speed age. Thank heaven for the microwave. But this kitchen wizard did not spring from divine inspiration alone. The story of the very first microwave oven can trace its roots to the terrors of war, American ingenuity, and one very important melted chocolate bar. The microwave developed from military technology. The wartime duty of microwave radiation was to be the magic behind radar.
Radar is like a searchlight, so pulses go out to the object, maybe 5 miles away, and then they're reflected back to the receiver, and that measures the distance.
Radar was perfected for use against the Nazis in the Second World War. It allowed the Allies to spot the enemy long before the enemy could reach them. In America, the main manufacturer of radar components during World War II was Massachusetts Raytheon Corporation.
We supplied about 80% of the microwave magnetrons. That's the tube that makes radar operate.
In early 1945, Raytheon engineer Percy Spencer was hard at work in the lab to improve these glorious machines. One afternoon, Spencer got hungry while he was working. He reached into his pocket for a chocolate bar and was flabbergasted to pull out a gooey mess.
When they stood in front of high-powered radar, they'd get warm. So that was something that was in the back of his mind. But when the chocolate bar melted, flash, the light bulb went on.
Spencer was inspired. He sent an assistant for a bag of uncooked popcorn. Then he spread the corn over the table near the magnetron and waited. Less than a minute later, the kernels began exploding. Spencer was now certain that the microwaves themselves were doing the cooking. And it was an auspicious beginning. Percy Spencer had made the first batch of what would become the world's most popular microwaved food, popcorn.
The microwave energy is like rubbing your hands together, only it rubs the molecules of food together as they are vibrating 3,000 million times a second.
Spencer could see that he was on the verge of a revolution. He knew housewives across America would rejoice if he could free them from their clunky, slow ovens. And just as important, the war would soon be ending, and Raytheon needed new products for the peacetime economy. Spencer was put in charge of a team of well over 100 engineers and mechanics. Their task? To overhaul this military technology into a household appliance.
The idea of encapsulating it in a box came afterwards. In fact, the original patent shows a conveyor belt going in front of an open-air magnetron.
But the final design looked very much like a conventional oven, with one big difference. Housed in a refrigerator-sized cabinet, the first working microwave oven weighed in around 600 pounds.
Oh, filthy language.
And stood just under 6 feet.
More filthy language.
An employee contest dubbed the new invention the radar range. The behemoth put out 3,000 watts of power.
So this is 3 times as powerful as the highest power unit on the sales on the market today, and maybe 5 times as powerful as the average unit.
It worked so fast that the company dubbed it stopwatch cooking.
Listen to these cooking times.
A few suggested cooking times: well-done steak in 50 seconds, baked potato in 2 minutes, fried egg in 12 seconds. Raytheon's chief executive, Lawrence Marshall, told his wife about it. Mrs. Marshall wanted to try out the new invention, so the CEO brought it home. Special plumbing had to be installed to service the water-cooled magnetron, but the family was thrilled. 2 years later, in 1947, Raytheon marketed a commercial model. It was essentially the same as the prototype, except more compact. It sold for $3,000, roughly equal to the average yearly household income at the time. The Wonder Cooker was just too expensive for Joe and Jane Average, so it was targeted to railroad dining cars, restaurants, and shipboard kitchens. But they weren't selling like hotcakes, even though they could make hotcakes in seconds.
It took many years for us to realize that you didn't need a radar quality magnetron to heat food.
About 20 years, in fact. After Raytheon bought the Amana Corporation in 1965, the radar range project was brought back to the front burner.
But after we bought Amana, they decided that they should have a kitchen top model. It's the hell with the high power.
Amana created a smaller, less powerful countertop model that cost only $500. By the end of the 70s, sales of microwave ovens had outpaced conventional ranges. No kitchen was complete without a compact, convenient microwave, including the kitchen of Raytheon CEO Lawrence Marshall. For 30 years, that first microwave had been humming in Mrs. Marshall's kitchen. Finally, in 1976, she asked for a replacement.
And she said that there were many advanced models out. Could I get her one of the new Amana models?
Norman Krim replaced Mrs. Marshall's microwave and brought the original one back to Raytheon. He understood the historical significance of the oven.
People have said that this is the first important improvement in cooking since the caveman was cooking on an open fire. but who knows?
The first microwave oven now resides in the Raytheon archives at their corporate campus in Lexington, Massachusetts.
And here is that world's first microwave oven, certainly not the size of convenience that we are used to today. Here's a still photo of that patent showed in the clip where the conveyor belt was the food exposed on the outside going around the magnetron. Some of you would way more enjoy watching your breakfast burrito go round and round and round in the morning. I don't think it was designed one kernel at a time to pop. So the original microwave ovens were known as radar ranges. They were pretty powerful. And you don't want to tell consumers, they're too powerful. They would not cause any type of physical harm. But you do need to tone down the amount of radiation required for the food preparation. So what they did was what any consumer product company does when they want their consumers to all change their models at once. They will redesign it to have a new look or a new color. And this is when all the rage went to, instead of these chrome and brown microwave ovens, we went to the white microwave ovens. And if you have one of these microwave ovens that it takes 4 people in the family to open up the door, and it's only dials, there's no digital readout whatsoever, it is fine. You are not going to have any ill effects from it. Maybe you have a nice antique in the home, but the microwave ovens that we have on the market today, very good ovens of convenience. If we were to ask you, how does a microwave oven work, besides you put the food in and press on and watch it go around gloriously, when you're pressing the power, pressing on to start the food process of cooking with microwave radiation, what you're doing is starting the magnetron, and that is the beam of microwaves. Microwaves have fans in them so that they can more readily distribute the particles, the waves in the microwave radiation band. And so those beams of microwaves are going to be scattered throughout and heat up your food. The key ingredient in our food that makes the microwave cooking process go much, much more efficiently is water. And some assembly would be required. Some of you have learned the recipe of water, where it's 2 parts hydrogen buffalo, 1 part oxygen buffalo for 1 water buffalo. So H2O. This is Wilma, the water molecule. She is 1 part oxygen, 2 parts hydrogen. And when you're placing your food in the microwave, it's the water content that's going to determine how well your food comes out cooked. Whether it's a plate of leftovers that you put in and it comes out as nuked, nothing like your dinner before. It's all about the water content, because what happens when you cause the microwaves to be circulated through the oven, you're going to have the water start to vibrate, start to oscillate. And the faster things oscillate and move, the warmer they get. And when water in the liquid form reaches a certain temperature, vibration rate, then it turns to steam. And it's that steam that actually ends up cooking your food. So if you put food in the microwave that has very low moisture content, it's not going to come out well at all. It's going to have that crispy, nuked feel, texture, and flavor about it. So if you're having leftovers, take a little bit of water and sprinkle it on your food to create water, or to have water to create the steam. Now, I'm not saying take your leftovers and hold it under the stream of water and it nearly flushes the food off the plate. Just put a little water in your hand, kind of sprinkle it, rain over the top of your food. Or you can take a mug of water, so halfway full mug of water, put it in the microwave oven and let that cook for about a minute first. So you kind of create a little bit of steam in the microwave first. Take the mug out, or leave the mug in if there's room, put your leftovers in, and then start the cooking process, and your food will come out better for the taste buds and overall appearance. Yes, physics provides you cooking tips occasionally. And if you are going to purchase a microwave for the sole purpose of the number one food produced or the microwave is used for, which is popcorn, make sure that you purchase a microwave that has the special popcorn setting. The reason being is not, oh great, perfect popcorn. It's that the distribution of the radiation is a little bit different, and the long-term use of the microwave is going to be better for you if it's got the popcorn option on there, which most of them do these days. Because if you think about it, how much water is in a popcorn kernel? Now, it cooks successfully because they're usually bathed in butter at the base of the bag. If we are to look at things that are cooked in the microwave, this is a snapshot through infrared radiation, another area of the electromagnetic spectrum, piggybacked here with microwaves. This is a thermal image, so infrared heat energy. This allows us to see the distribution of heat. Now, in this particular thermogram image, the brighter the color, yellowy white, is meaning warmer temperatures, and the darker temperatures, cooler temperatures. And as you can see, microwaves have the tendency to cook from the outside in. This is your classic mac and cheese. You'll see these corners are very intensely hot, and even this little dimple is in there. And the containers are plastic. They're microwave safe plastic, but you have to realize not only is the mac and cheese oscillating back and forth at high rates, but so is the plastic. And so there's always a little bit of concern with people and plastics in the microwaves, and in the sense that you get finished eating your microwave, you're like, oh, there's this little more translucent corner. Well, you may have ingested some of the plastic. Now, in no means am I trying to incite any level of panic. All of us living on planet Earth in the 21st century, science has shown through massive data collection that each of us unwittingly consume about a credit card's worth of plastic each week. And we're all still here pretty much to tell about it. But you just want to be mindful. If you have the option to put glass into the microwave, your food put into the glass, I'd say that's a better choice for you. If you heat glass up to really high temperatures, it's going to go back to its former state, if you will, of sand. And we've all eaten plenty of sand, I'm sure. So again, not trying to raise the alarm. Your microwave oven's perfectly safe. The microwave dishes, microwave safe plastic, they're perfectly fine. But if your oven of convenience, the microwave, is your sole purpose of heated foods into your body, just, glass might be a little bit better way for you to go. Here is your breakfast burritos, or any burrito, in a microwave, and you'll see this kind of cooking from the outside in, and why you bite into the middle. It's still a little bit cold, or sometimes even frozen. A microwave uses more electricity to power its clock than it does to heat your food. Microwaves can also be used for wireless communications, for our smart devices, cell phones. And again, this is in your area of the higher frequencies of microwaves, lower frequencies relative to each other of radio waves. So you can have radio waves for cellular devices, wireless communication, as well as partial in the microwave band. And these cell towers that you see are most certainly making use of microwave radiation. So let's put this couple bits of information together. Mobile phones use microwave energy. We know that microwave ovens can cook food. Can a mobile phone cause heating? Now, I don't mean in the sense of rogue YouTube videos that are staged, where you have a phone and then it appears the kernels are put on and then are immediately turned into popcorn. We're talking more of heat distribution. This is going back to infrared images, so looking at the heat, which is energy, of the result of having a cellular phone conversation. So rather than texting, you actually put the phone to your ear and talk to someone, or someone listens to you, vice versa. I believe this was about a 10-minute phone call, and 10 minutes, the 0.2 of a degree Celsius rise in temperature was registered. Notice the side here is trying to show how much into the skull, depth into the skull, that these microwaves penetrated. Not very much. Mobile phones that use microwave radiation, quite safe. Again, not trying to send alarm up of, oh, Smith said if I use my cell phone I have cancer. No, not at all. Okay, I'm just showing you that, yeah, these devices do produce heat, and I'm sure you've been on them for long periods of time where you have felt the heat itself. And then this is just the image before the conversation and then after the conversation. And just to confirm, it wasn't a heated discussion, no pun intended. It was a calm conversation. This is a study from the University of Utah, 96, showing a conversation of a cell phone, again for not a great length of time, versus the adult skull penetration, 10-year-old child, and a 5-year-old child, where you're probably aware that the skull has not fully calcified, hardened within the 5-year-old compared to a 10-year-old and an adult. Again, I am in no way saying you run home, hey, Smith said that time I listened to Grandma on the phone tell me happy birthday when I was 4, I'm now gonna die. I'm not saying that at all. I'm just making you aware that microwave radiation, like all forms of radiation, is giving off, emitting waves or particles. They're not necessarily things that are contained in black boxes of microwaves, contained within the black boxes of phones. These radiation waves are constantly being emitted, which is a good thing. We can't see all of that radiation that fills up the world in which we interact with. In determining weather patterns and being able to predict actually makes use of microwave radiation, similar to the radar in which you're able to determine incoming storm systems and the rates of travel and predict when will this storm front hit us, when will it pass. So those are just a few of the applications of the section of the, or I should say area of the electromagnetic spectrum that Heinrich Hertz discovers in 1888.